Parameter s of function eval contains an expression involving unsigned integers and operators plus and minus. There is at least one integer, followed by 0 or more operator-operand pairs. There may be any number of blanks at the beginning and end of s, and between operators and integers. Function eval evaluates the expression in s and returns the value. The first point to note is that there may be spaces all over the place. If we remove them, then, following each integer, except the last, there would be an operator plus or minus, and following each operator would be a digit. That could simplify our task, so we start off with a statement to remove all blanks. Now, the tendency is to immediately write a loop to process parameter s, looking at one character at a time. This sudden introduction of a loop leads to all sorts of complications. Before introducing such a loop, think more about the situation. Note that there is always the first operand, and that may be all there is. So we think of writing a statement comment that uses two new local variables. Variable ans now contains the value of the first integer, and k contains the index of the character following the first integer, as shown in the diagram. Now, the rest of s to process, s sub k dot dot, contains a sequence of 0 or more operator pairs. Therefore, we think of writing a loop that at each iteration processes one operator-operand pair. This is the important step of having the structure of the loop reflect the structure of the data. How is an operator-operand pair to be processed? Its contribution to the answer can be accumulated in variable ans, and k can be set to the position following the pair. Note how the obvious loop invariant is a simple generalization of the precondition shown before. Instead of the first segment containing the first integer, it contains the part of the expression processed thus far. Note that we avoided figuring out how to implement the two statement comments, preferring to get the overall structure down first. After the loop, of course, ans must be returned. The first statement comment requires finding the end of the integer that starts at s sub 0. The second one requires finding the end of the integer that starts at s sub k plus 1, after the operator. The same kind of task must be done in two places. So, we use the mañana principle and write a function header and specification, to be written later. It is given the string s and an index h. Character h is a digit, and the method should return the index following the last digit of the integer that begins in s sub h. We now implement the first statement comment. Call getEnd to find the index following the integer and store the index in k. Then use function parseInt to extract the integer in s sub 0 through k minus 1 and store its value in ans. We implement the second statement comment. First, save the index of the start of the operator-operand pair in h. Then, call getEnd to find the index following the integer and store the index in k. Then, use function parseInt to extract the integer in s sub h dot dot k minus 1 and store its value in n. Finally, use a conditional expression based on operator s sub h to add n to ans or subtract n from ans. This completes the development of function eval. It remains to implement function getEnd. It has a loop that checks successive characters until either the end of the string or a non-digit is reached.